Hey there guys, this is the AQA 2019 AS Level Maths Paper 2, Pure and Stats. Let's do this. Number 1. Find the gradient of the curve y equals e to the minus 3x at the point where it crosses the y-axis. Okay, so we need to differentiate and substitute in x equals 0. So dy by dx is, so to differentiate exponentials, we differentiate the power, stick that out front, and then multiply the original function. So here we're going to get minus 3 e to the minus 3x. Now when x is 0, dy by dx is minus 3e to the 0, which is just minus 3. Number 2. Find the centre of the circle. X squared add y squared add 4x minus 6y is 12. To do this, we must write it as x minus a squared and y minus b squared is equal to r squared. So we're completing this square twice. So x squared add 4x is x add 2 squared minus 4, and then y squared minus 6y is y minus 3 squared minus 9. So we can get that as x add 2 squared add y minus 3 squared is equal to 25. So the centre is minus 2, positive 3. And the radius would be 5. Number 3. It is given that sine theta equals 0.1 and theta is between 180 and 270 degrees. Find the exact value of cos theta. Okay, so we need to transform sine into cos. To do that, we're going to use sine squared add cos squared equals 1. So from that we can get sine squared is 1 minus cos squared. Okay, so if we square both sides, we get sine squared theta is equal to 0.01. So 1 minus cos squared theta is 0.01. Now if we add cos squared, subtract 0.01, we can get cos squared theta is equal to 0.99. Now that would tell us then that cos theta can be positive or negative root 0.99, but it can only be 1. Now we need to think about the interval for theta. So cos between 180 and 270 looks like that. So we can see between 180 and 270 degrees, cos is negative. So cos theta here is minus root 0.99. Just a quick note on this one as well, if you're using the mark scheme, they don't have the answer in this form. What they have is, or what they've done, is used 0.99, it's 99/100ths. So we have minus root 99/100ths. Now we can say that is minus root 9/100 times 11. Sorry, root 11. So then we can say that is minus 3/10 root 11. Number 4. For x greater than 0, we want to prove this identity with logs. Okay, so starting on the left, when you add logs together, you multiply the insides. So log 10 x to the 4 over 100 add log 10 of 9x is going to be log 10 of 9x to the power 5 over 100. Then we have minus log 10x cubed. Okay, now when we subtract logs, whatever's inside the second one divides the inside of the first one. So we then have log 10 of 9x to the power 5 over 100x cubed. So that's log 10 of 9x squared over 100. Okay, now everything there is square. So we could try this as log 10 of 3x over 10 all squared Now, using the power rule of logs, this is now 2 log 10 of 3x over 10. Next then we can split with a log, so we can now say this is 2 lots of log 10 3x minus log 10 of 10. Now, log 10 of 10 is just saying what power is 10 of 10. So 10 to the power of 1 is 10. So log 10 is 1. So we do indeed have 2 lots minus 1 add log 10 3x. A triangular prism has this triangle as its cross-section. The length of the prism is 300 millimeters. We want to work out the volume to 3 sig figs. Okay, so work out the area of this triangle and multiply by 300. So, at the moment, we can't find the area of the triangle. We obviously don't know the height, so all we're going to need is 2 sides coming out of an angle and then use trig area. So, first thing we can do is find the angle at the top of the triangle. So that's going to be 125. Okay, now I'm going to find the top right side length. So I'm going to call it x. So I can use the sine rule. So I can say that x over sine 30 is 40 over sine 125. Now we want x, so multiply through by sine 30, and you should get x is 24.4 millimeters. Okay, so now that we know that, we now have an angle with 2 sides coming out of it, so we can now work out the area. So, the area is 1/2 times 24.4 times 40 sine 25. Now stick that in your calculator and we should get 206.2 millimeters squared. So then the volume is 300 millimeters times 206.2 millimeters squared. So, for that, 2, 3 sig figs, we will get 61,900 millimeters cubed. Sixth, a curve is equation y equals 2 over x root x. The area enclosed between the curve, the x-axis, the lines x equals 1 and x equals a has area 3 units. Given that a is greater than 1, find the value of a. Okay, so this is integration area under a curve. So, first of all, let's rewrite y. So, 2 over x root x is 2 over x to the 1 times x to the half. So it's 2 over x to the 3 halves, which is 2x to the minus 3 halves. Now we know the area is the integral between 1 and a of 2x to the minus 3 halves. Now, we also know that that is 3. So, if we integrate, okay, so x to the minus 3 halves goes up by 1 whole power, so it's going to go up to x to the minus 1 half. And then we divide by the new power. So 2 divided by minus 1 half is minus 4. Okay, now at this point I'll probably write it back in root form. So we've now got minus 4 over root x. Okay, now whack in the limits. So we're going to get minus 4 over root a minus 4 over 1. So minus 4 is equal to 3. So there we have minus 4 over root x, root a add 4 is equal to 3. So, rearrange this a bit and we get 1 is 4 over root a. So, root a is 4. So, finally, a is 16. Okay, number 7, the point A, A3 and B, 10, 6 lie on a circle. AB is a diameter of the circle and passes through 2, 4. The equation of the circle is x minus c squared add y minus d squared equals e squared, where c, d and e are rational numbers. Find the values of a, c, d and e. Okay, quite tricky. So, the diameter is the key to pretty much all of this. We know 2 points that lie on A, B. We know the midpoint of the diameter is the centre, and then we can find the length from the centre to the circle, which is the radius. So, let's find the equation of AB. So, for the gradient, the 2 points we know are 10, 6 and 2, 4. So the gradient is 6 take 4. Over 10 take 2. Which gives us 2 over 8, so 1/4. Okay, so now we know that y is x over 4. Add a constant. We can't use c because that's already in the question, so I'm going to use k. Okay, now we know when x is 2, y is 4. So, we get 4 is equal to 2 over 4, so a half. Add k. That tells us k is 3.5 or 7 halves. So, the line AB is y equals x over 4 and 7 halves. Okay, now our first mission is to find the x coordinate at A. So, we know when x is A, y is 3. So we get 3 is A over 4 at 7 halves. Now if we multiply through by 4, we get 12 is A, add 14. So A is minus 2. Okay, so now we know the two ends of the diameter. So we now know that A is minus 2, 3. And B again is 10, 6. Now because AB is a diameter of the circle, the midpoint of AB is the center of the circle. So we now want the midpoint. So that's the average of the coordinates. So the x is minus 2 add 10 over 2. And y is 3 add 6 over 2. So, there we have 8 over 2, so that's 4. And 9 over 2 is 9 halves. So, now we can say then that C is 4 and D is 9 halves. Now the final thing we need to do is find E. So we know 2 points that lie on the circle. We now know the numbers in the brackets. So we can just sub in the values from one of the points. So I'm going to put in 10, 6. So x is 10. Y is 6. So that's going to give us 10 minus 4 squared. So 6 squared. Add 6 minus, now I'm going to think of 9 halves as 4.5. So 6 minus 4.5 is 1.5. So we get 36. Add 2.25 is equal to E. So E is 38.25. Number 8. A curve has equation y is x cubed add bx squared add qx minus 45. The curve passes through the point R, 2, 3. The gradient at R is 8. Find the values of P and Q. Okay, so we have 2 bits of info that we can form equations from. So this is going to become simultaneous equations. So we know that when y is 3, x is 2. So x is 2, y is 3. It gives us 3 is 8. Add 4p. Add 2q. Minus 45. So, from that, we can get 8 minus 45 is minus 37. So, add 37 to both sides, we get 40. Is 4p add 2q. Divide through by 2, we get 20. Is 2p add q. Okay, there's one equation. So, try this. So I'm going to write it as 2p add q is 20. Okay, next we know the gradient at r is 8. So we need to differentiate. So dy by dx is 3x squared add 2bx plus q. Now we know when x is 2, dy by dx is 8. So there, we're going to get 8 is 3x squared, so that's 12. Add 2 times 2p, so 4p. Add q. So there, we have minus 4 is 4p add q. Okay, so now we need to solve these two. So, it's quite nice because they both have a q. So we need to do one equation minus the other. So it doesn't really matter. I'm going to do 1 take 2. So 2p minus 4p is minus 2p. Q minus q, pi by q. And then 20 minus minus 4 is 24. So P is minus 12. Okay, then to get Q, sub that in. So I'm going to put it into number 1. So then we know minus 24. Add Q is 20. Therefore, Q is 44. Okay, then for part B, calculate the area enclosed between the normal to the curve at R and the coordinate axes. Okay, so we don't care about the curve anymore, apart from its gradient at R. So we know the gradient of the curve at R was 8, so the gradient of the normal is going to be minus 1/8. So the normal has an equation of the form y is minus 1/8 x add c. Okay, now we need to find c, so we can again use the coordinates of r, so x is 2, y is 3. So we get 3 is minus 2/8, so minus a quarter. Add c. Add the quarter, and we get c is 3 1/4, so 13 quarters. Okay, so now we know the normal is y is minus 1/8 x. Add 13 quarters. Okay, so all that's done is the normal is a straight line, so what we're forming here is a right-angled triangle. We now know the height of the triangle is 13 quarters. What we now need is the base, so we need the x-intercept. So, for the x-intercept, y is 0. So that's going to give us 0 is minus 1/8 x at 13 quarters. So add the x term, multiply by 8, and we get x is 26. So the base of the triangle is 26 long. So the area, base times height, divided by 2. So we now have then 26 times 13 quarters all over 2 which is going to give us 169 quarters. Okay, number 9, a curve C has equation y equals f of x, where f of x is x minus 2 times x minus 3 squared. We want to find the exact coordinates of the turning points of C and determine the nature of each turning point. Okay, so at turning points, dy by dx is 0. To be able to differentiate, we need to expand the brackets. So let's do that first. So we can say that y is x minus 2 times x squared minus 6x add 9. Now, expand that and make sure you can get x cubed minus 8x squared add 21x minus 18. Okay, so at this point you would want to say at turning points dy by dx is 0. Very important to write down things like that to get full marks. So now we're going to differentiate. So dy by dx is 3x squared minus 16x plus 21. Okay, now we're going to set that equal to 0 and solve. Okay, so we need to factorize it. So we're going to need a 3x and an x. Okay, now numbers that multiply together to 21 is only really 3 and 7. So, if we put, now it's also positive 21, but negative in the middle, so both numbers are negative. So if we put a minus 3 there, that gets us minus 9x, and then a minus 7 does the job. So that then tells us x is 7/3 and x is 3. Okay, so before we worry about their nature, let's find the y coordinates. So, to do that, we're going to use the bracket form of the function. So, when x is 7/3, your y is 7/3 minus 2 times 7/3 minus 3 squared. So, that's going to give us 1/3 times minus 2/3 squared, so 4/9. And that is 4/27. Okay, and then much nicer when x is 3, y is 3 minus 2 times 3 minus 3 squared, which is 0. So the turning points are 7/3 4/27 and 3, 0. Okay, now we need to classify their nature. Okay, now to do that, we use the second derivative. So we need to differentiate again. So d squared y by dx squared is going to be 6x minus 16. Okay, now we sub in the x values. So when x is 7/3, we are going to get 42/3 minus 16 now that's 14 minus 16, so that's minus 2. Now because that's negative, that means this point is a maximum. And then when x is 3, we get 18 minus 16 which is 2. Now that's positive, so 3, 0 is a minimum. Okay, then for part B, state the coordinates of the turning points of f of x at 1 minus 4. So this is a translation by, well, it's moving us one place left, 4 down. So minus 1, minus 4. So 7/3 4/27 is going to map to 4/3 and then 4/27 minus 108/27, so minus 104/27. And then 3, 0 it's going to map to 2 minus 4. Number 10. As part of an experiment, Zena puts a bucket of hot water outside on a day where the temperature outside is 0 degrees Celsius. She measures the temperature of the water after 10 minutes and after 20 minutes. Her results are in the table. She models the relationship between theta, the temperature of the water, degrees Celsius, and T, the time in minutes, as theta is A times 10 to the minus KT. A and K are constants. Part A, using T equals 0, explain how the value of A relates to the experiment. Okay, so when T is 0, theta is A times 10 to the power 0, so theta is just A. So A is just the initial temperature of the water. Part B, show that log 10 theta is log 10A minus KT. Okay, so log both sides, we get log 10 theta is log 10 A times 10 to the minus KT. Now, on the right, we can split that into 2 logs. So, log 10a add log 10 10 to the minus kt. Now, log base 10 of 10 to the minus kt is asking what power do we set 10 to get 10 to the minus kt. So it's just minus kt. So we do indeed have log 10a minus kt. Using these results, calculate the values of a and k. Okay, so in the table we have two sets of results. So we know that when t is 10, theta is 30. So we can say 30 is a times 10 to the minus 10k. And we also know when t is 20, theta is 12. So we can say 12 is a times 10 to the minus 20k. Alright, so we need to get rid of one of the variables. Now, we can't do this by addition or subtraction, but we can using division. So, if we call these 1 and 2, then I'm gonna do number 1 divided by number 2. So that's going to give us 30 over 12. Now the point for doing this is that the a's are common factors, so they disappear. So we're going to get 10 to the minus 10k divided by 10 to the minus 20k. Okay then, so we got 2.5 is equal to 10 to the positive 10k. From there then, if we take a log base 10 of both sides, we get log 10 of 2.5 is 10k divided by 10. K is 0.0398. Okay, so now to find A, we can use one of the initial values again. So I'm going to use theta is 30, t is 10. So we now know 30 is a times 10 to the minus 10 times 0.0398. So to the minus 0.398. Now divide through by the 10 term and we will get A is 75. Zena then states that the temperature of the water will be less than 1 degree after 45 minutes. Determine whether the model supports this statement. So, whack T equals 45 into the model. So, for we should get theta is 1.21. Which is not less than 1 degree. So, the model does not support the statement. Okay, then the final part, we want to explain why the model is unlikely to give the accurate temperature of the water after 45 minutes. So, think about it logically. Temperature fluctuates. It doesn't like to stay constant. So it's very unlikely the outside temperature will remain at 0 degrees for a long period of time. A survey is undertaken to find the most popular political party in London. The first 1,100 available people in London are surveyed. Identify the name of the sampling method. So we're sampling whoever we can find its opportunity. 12. Manny is studying the price and number of pages in a random sample of books. He calculates the product moment correlation coefficient as 1.05. Which statement best describes the value of 1.05? So, PMCs can only be between -1 and 1. So, this is definitely incorrect. Number 13. Denzel wants to buy a car with a particular type of propulsion other than petrol or diesel. He takes a sample from the large data set of CO2 emissions grams per kilometre for one particular type of propulsion. The sample is as follows. Part A. Using your knowledge of the large data set, state which propulsion type the sample is for, giving a reason for your answer. Okay, don't worry about this part too much. The large data set changes every year, so you won't be using this one. What they were looking for here is electric, because that's the only propulsion type with this many data. Again though, your large data set will be different, so don't worry. And part B wants us to calculate the mean, so you can use your statistical calculator to do B and C. So we will get X bar is 72.375. And I guess grams per kilometre. And part C wants the standard deviation. Again, the calculator can do that. So sigma is 28.7. Denzel believes the value 13 is an outlier. Any value more than 2 standard deviations from the mean can be regarded as an outlier. Verify Denzel's claim is correct. Okay, so we need to do then 72.375 minus 2 times 28.7. Now that gives us 14.975. Now 13 is less than that. Therefore, his claim is correct. State what effect, if any, removing the value of 13 from the sample will have on the standard deviation. Okay, so standard deviation is like the average difference of data from the mean. Because 13 is an outlier, it's a lot further from the mean than it should be, which is making the average difference bigger. So if we remove it from the sample, then the average difference, standard deviation, decreases. Number 14. A probability distribution is given by the probability x equals x is c times 4 minus x, where x is 0, 1, 2, or 3, and c is a constant. Part A. Show that c is 1/10. Okay, so we know all the possible probabilities have to add together to 1. So, when x is 0, we get 4c. When x is 1, we get 3c. When x is 2, we get 2c. When x is 3, we get 1c. Now those are all the possible probabilities. They add up to 1. So on the left we have 10c. Therefore, c is indeed 1/10. Part B. Calculate the probability x is greater than or equal to 1. Okay, so x can only be 0, 1, 2, or 3. So the only probability we don't want is the probability x is 0. So we can say the probability x is greater than or equal to 1 is 1 minus the probability x is 0. Now we know the probability x is 0 was 4c, so 4 times a tenth. So we get 6/10 or 3/5. Two independent events A and B are such that the probability of A is 0.2, the probability of A union B is 0.8. Find the probability of B. Okay, so what do we know? They are independent. So that means the probability of A intersection B is equal to the probability of A times the probability of B. Okay, now that isn't much use. What else do we know yet? Anyway, we also know A union B is the probability of A at the probability of B minus the intersection. Okay, so things are starting to get useful. So let's sub in some values. So we know the union is 0.8. Probability of A is 0.2. Now, we can also say then that we know the probability of A. So we have minus 0.2 times the probability of B. Okay, now we can subtract 0.2, so we get 0.6. Now on the right we have probability of B minus 0.2, the probability of B. So we have 0.8, the probability of B. From that then, we can get the probability of B is 0.6 over 0.8. Which is 0.75. Part B. Find the probability of A intersection B. So we know that that's 0.2 times 0.75, which is 0.15. Part C. State with a reason whether or not A and B are mutually exclusive. So that means they can't happen at the same time. But we know from above they can happen at the same time. The probability is 0.15. So we would say no, because the probability of A intersection B is not 0. As 16 we have a hypothesis test. So Andrea is the manager of a company that makes mobile phone chargers. In the past, she has found 12% of all chargers are faulty. She decides to move the manufacture of chargers to a different factory. She samples 60 of these new chargers and finds 4 are faulty. Investigate at the 10% level of significance whether the proportion of faulty chargers has reduced. Okay, first thing to do, define a variable. So, let's say let x be the number of faulty charges. Okay, next we need the hypotheses. So, H0, the null hypothesis. That's the one where the probability stays the same, so the probability is 0.12. Now we're testing whether or not that has reduced. So the alternate hypothesis, H1, is that the probability is less than 0.12. Now what we're interested in is the probability that when the proportion of faulty charges was 0.12, what was the probability that in a sample of 60, 4 or fewer were faulty? So we set up the distribution under H0. So we say under H0 x follows a binomial distribution, n is 60 and p is 0.12. So we now test the probability x is less than or equal to 4. So on your calculators you want binomial CD, n is 60, p is 0.12 and x is 4, and we will get 0.139. Now, we were testing at the 10% level. If this probability had been less than 10%, we would accept H1. Because it's more than 10%, 13.9%, we reject H1. So, really now we should say 0.139 is bigger than 0.1, which is 10%. So, we reject H1. And then the final thing we need to do is a closing statement. So, something along the lines of, there is no significant evidence the proportion of faulty charges has reduced. Good. Okay, and then for part B, we need to state in context two assumptions we have made for the distribution we used in part A to be valid. So, our distribution was binomial. To use a binomial distribution, the probability must remain fixed and events must be independent of each other. So, in context, we would want to say the probability that one charger is faulty is independent of any other charger. That's one thing. And the other would be, we've also assumed the probability of a charger being faulty is fixed at 0.12. Boom. And guys, that's the paper done. Really hope it's helped. Remember to check out all the content linked in the description. I got loads of stuff coming for A-Level Maths Year 2 too. So make sure you subscribe, share the channel around, be awesome. For now, take it easy, take care.